Good morning. Well, actually, probably not morning for most of you. Well, it's hard to say because my friend Richard says we have folks from all over the globe here. So I'm not sure where you're from or what time it is where you're at, but whatever time it is, good day, and thank you for joining me. I appreciate it. This is my session, a little bit different session than maybe what you might have seen or heard during this conference, but I think you'll enjoy it. Hopefully it'll entertain you. Hopefully you will learn a little bit. And I'm excited to give this talk because I've given it a few times, but I've not given it really yet to an audience of strictly Java developers. And I'm really excited about that because obviously Java is a big part of this application that I've built. And I'm really excited about the technology behind the application. As you see on my title screen here, I used all kinds of different technologies, but a big part of that is Java and Micronaut. Obviously, I'm a huge fan of the Micronaut framework. And let's get into it. We're going to talk about my journey to create hot sauce, believe it or not, using IoT devices, messaging, Micronaut, SQL, all kinds of fun stuff in the cloud. And I made that hot sauce by actually automating and monitoring my seedlings that I grew into chili peppers. So let's get into it. A little bit about me. I am T.Sharp. Again, I am a developer advocate. That means I get to talk to people like you, learn about the awesome technologies that you're using, how you're using them, what you like about them, what you don't like about them, all kinds of stuff like that. And I use that feedback to bring back to my organization to talk to our product managers, project managers, engineering teams, and we use that feedback to make better products for you. Also a little bit of evangelism and talking about our products and services, but far from a marketing or sales type pitch where I'm actually giving you like sales pitches, none of that kind of stuff from me, just building cool stuff, showing you how I built it, and hopefully inspiring you to do the same, or inspiring you to think about technology in a different way than maybe you did before. My Twitter handle is Recursive Codes. You can find me on all the socials. YouTube, I have a YouTube channel. I haven't updated it in a little bit, but I hope to get back to making some video content soon. My blog is recursive.codes, and you can find me on GitHub, all kinds of things like that. So here's my promise to you. In this session, in the next 50 minutes, oh, I have not shared my screen yet. I apologize for that. Thank you for the heads up. Rookie mistake. These virtual conferences are going to kill me. No, anyways, there we go. Sharing my screen. Sorry about that. So back to my previous slide, in case you wanted to catch any of that information, here is my About Me slide. Those are my two little dogs. One's a little dachshund, and the other is a mutt, but they're good dogs. I also have a pig and 11 chickens out back. So if you hear any crowing, you might hear my rooster crowing, but other than that, don't be worried. It's all under control. So here's my promise to you. And let me open up the chat real quick on the other screen, just in case there are any questions. Well, I don't think I could do that. Actually, do it from here. That's right. All right, excellent. So I have the chat open in case there are any questions. It's not full screen. Are you seeing the screen okay? I know it's not 100% full screen, but I'm going to switch back and forth. So hopefully you can see this quite good anyways. Okay, excellent. So here's my promise. In this session, I will show you how I used microcontrollers, some sensors, and the cloud to create the world's greatest hot sauce. Of course, that's based on my opinion, but I did share it with some friends and they found it quite good. I found it quite good, and it was just a fun project to work on. So we'll go with that. So the motivation behind this project, why did I do this? What kind of led me to this project? Well, personally, myself in 2020, I found myself stuck at home quite a bit. And I imagine it's probably the same for a lot of you, where essentially we had a pandemic. So there was really not much to do, not not anywhere to go. So we were all kind of just stuck at home, trying to find projects that would help keep us sane, right? Well, for me, I found this motivation on a trip to what they call the farmers market, which is here in the US. I'm not sure if they have them where you are, but here in the US, they have a lot of these open air markets where local farmers and merchants will come and they'll set up tables and they will sell their vegetables or their fruits or their crafts or things like this. And so it's this nice outdoor place where you can go and you can buy vegetables and things like that. So I was walking around, of course, with my mask on and proper social distancing and all that good stuff. But I was walking around one time and I saw these chili peppers that you see on your screen here. And one of my personal passions outside of code and technology and things like that, one of my personal passions is food. I love to eat. I love to cook. I just love everything about food. And I always have. It's just been a passion that I've had since I was very young. If I didn't go into coding, I would have probably gone into being a chef or something like that. So I saw these peppers and I thought, well, a lot of people these days are making sourdough bread. That was the big thing back when the pandemic started. Everybody was making sourdough bread or baking their own bread. And I thought, well, this would be a fun project. I could get these peppers and I could make some hot sauce. I love spicy food. I love hot things. So I grabbed a bunch of these chili peppers. I brought them home and I did a little research, looked up some recipes online. I chopped them up, threw them in a jar, put a little garlic, little onion, things like that in the jar, and salt water, brine solution. And I put that in the jar and I set them aside, put a lid on them, set them aside to ferment. And a few weeks later, I opened them up, took them out, blended it up, added a little vinegar, and created hot sauce. So this is the product of my first attempt at making hot sauce. Kind of two different varieties there based on different peppers that I use, things like that. But it was really good. I really liked it. I really enjoyed it. It gave me something to do every day. It gave me kind of a little project to keep tabs on and keep researching and things like that. So this is what I ended up creating. And around January of this year, I started thinking about this project and I thought, well, I'd like to do this again this year, but this time, instead of buying these peppers, what if I grew them myself? What if I actually grew them from seeds and planted them in the ground eventually and used these peppers that I grew myself to create my hot sauce? And I thought, well, this would be another great project, something to keep me busy, help me to kill the time as I'm stuck at home still another year. And I started thinking about how can I combine this project with my other passions, my passions for technology, for IoT devices and sensors and things like that. And so I thought the perfect way to do this would be to create a system that helps me monitor and automate the process of growing these seedlings. So I started them off indoors, actually right here in this office, and planted them in a little seedling tray. And I'll show you in a minute the system that I came up with to actually automate and monitor the growth process. So the first thing that I did was did some research. I'm not a really good gardener. I've never really had much luck with growing things myself, but I thought it can't be that hard, of course, right? And of course learned that, yes, it is kind of difficult at times, but essentially I came up with these objectives, these 5 different metrics that I wanted to measure and basically monitor and try to ensure through technology that I reach these metrics, right? So air temperature, I wanted the daytime temperature to be between 18 and 26 C. The soil temperature, my research told me that 26 C was the ideal temperature during the day. Moisture, the actual soil moisture, how much water was in the soil, 70 to 80%. Humidity, 50 to 70%, and light, the actual amount of sunlight, should be greater than 1600 lux. At nighttime, these numbers change a little bit. Obviously, the soil temperature can be a little cooler, There's going to be less light at night. And these are the ideal metrics that I wanted to shoot for and really were my target for this project to see if I could actually reach these metrics, right? So the architecture is very simple. As you see here on the left-hand side, this is my seedlings and my sensors and my microcontrollers. And essentially what I do is I read those temperatures and values, and on a set time period, a set interval, I publish those readings to a messaging queue. In this case, it's a RabbitMQ server that I have running in the cloud. And that's actually on a very lightweight, free instance in the cloud, so I don't have to pay for that or anything. I'm able to run that messaging queue, and I use that for a lot of my projects. It's just a RabbitMQ, MQTT messaging queue, messaging broker that I have in the cloud. From there, I would have the Micronaut application, which consumes that messaging queue. And from there, it does two things. It, one, pushes data to an interface, a front end that I can visualize and let me get at a glance, see what's going on, see how things are trending, have some basic reporting so that I could look at that data, especially now after the fact, and see, okay, how do my results that actually grew, how do they compare to these reports that I have? Was I successful in reaching these metrics, right? Also, the data is then persisted to the database so that I could do those kind of reporting things later on. Now let's take a look at a demo. I'm actually going to show you the unit and show you how it works. And if you want to follow along, you could hit that link, or you could just watch me here because I'm going to pull it up in my browser in just a second. So if we hop over to the browser and we take a look, you can see this is my web interface that I came up with. And I'm actually going to move this over to the side, and I'm going to move this window up here as well. So this is a webcam that I have on my desk, and it shows the actual unit over here. And again, this is the actual web interface on the right-hand side of the screen. Hopefully you can see that well. My fonts and everything are all up and good. Let me quickly turn on my hotspot on my phone because that's what I've configured this to connect through. And what I'll do is I will, in just a second, I will give this some power and we'll see how it works. Now, this is the actual kind of little case that I made for the microcontroller unit. I 3D printed it on my 3D printer, and it basically contains the microcontroller, which is down at the bottom there, soldered to this breadboard. And all of my wires here are connected up to that. And the sensors themselves are coming out the side, and I'll show you those real quickly. So this is a temperature and humidity sensor. It's called a DHT11, and it allows me to measure the air temperature as well as the humidity in the air. This is a water sensor, and this is how I monitored the actual soil moisture in the moisture in the soil. As you can see here, it's corroded a little bit, and I find that a little odd. That is a sensor that's meant to go into moist environments and measure the moisture actually corrodes. But I did learn a lesson that they make capacitive moisture sensors that you can buy that have like a rubber coating on those. And I think I'll switch out to that one next year. It still reads just fine, but of course it had a little issue with corrosion there. This is an actual probe thermometer, and I use this probe thermometer to monitor the soil temperature. And finally, a light sensor. This is actually a sensor that reads the light level and reports that out. Now, the automation part of the process happens with a little bit of sensors and other things that I'll show you here. This is an actual heat mat. So this is like a rubber pad that I put under the seedling tray, and I plug that into this outlet here. And this outlet is a little special. It's connected up to the microcontroller through this wire, and there's a relay inside of this outlet junction box. You can't see it, but it's in there, And the relay allows me to turn the outlet on and off based on whenever I want to turn it on and off. So essentially what I could do is with this probe thermometer, I monitor the soil temperature. If it's getting too hot above my threshold, I turn the outlet off. If it's getting too cold, I turn the outlet on and it brings the temperature of the soil back up to my target temperature. So it's kind of a neat little process, and we'll plug it in here and show you how it works, or show you it working. So plug that in. There is a little mini OLED display here. It's really, really tiny. You probably can't see that very well, but it's basically so I could have a little readout just by looking at the box of the current values. It shows me the air, soil, humidity, moisture, and light, and the status of the outlet. Let me see if I can bring that up there, if I can get that into focus. Try to focus that. That's going to be difficult to focus on, but I think you get the picture, and we'll show you the values in the web application. So you can see here, this little LED light is plugged into this outlet. And as you can see, the outlet is currently on. The LED is on, meaning that the outlet is currently powered. If we go over to the web application, you can see that again, that the outlet is on. The current air temperature is 75 degrees Fahrenheit. I apologize for not having Celsius here. I don't know the conversion, but yeah, so actually I do know the conversion, 28C. If I look at the 22C, if I look at the actual OLED display, the air temperature is 24C, the soil temperature is currently showing 22C. The moisture is at 0% because the sensor is not currently plugged into anything, and the humidity is at 86%. The light is at 19 lux. If I actually take the light sensor here and I shine a flashlight onto it, you can see the light sensor reading goes up to just about 3,700, 3,400 in that area. So the light sensor is working as expected. The probe thermometer, if I take that here, and if I actually warm that up by holding it in my hand like this, you should see the soil temperature reading going up over here. And as you see, we hit 82 degrees and the LED over here has gone off. So we're above that 80-degree threshold that I wanted to keep the temperature at. So as soon as we got above that 80 degrees, it turned the outlet off, meaning that the heat mat itself would be turned off. So down here in the application, you see some real-time charts. These are kind of nice, gives you a nice way to track in real time the actual fluctuations of temperature, the soil temperature down here with a actual marker saying when the outlet got turned off, and the moisture. If we, let me test that real quick. If we actually kind of got the sensor wet here, we should see that reading change as well. And you can see we're up to 40% moisture just by getting that sensor a little wet. You can see how that works. And yeah, basically that's it. That is the web application. And if we jump over here to the reports page, we can see that I've also got some different reports that I've created to allow me, as I said, to track the values over time, allow me to kind of look at the overall progress and see how things are doing and things like that. My reports page does not seem like it wants to load. So we'll give it just a second. And it has decided not to load at this time. We'll try to come back to that. All right, let's go back to the slides and we will take another look at that. All right. Excellent. So I want to look at the code now and show you how everything works. I want to start with the SQL schema behind everything because I think it's kind of interesting, the choices that I made when it came to dealing with this project. And before I do that, let's think about the actual data that I'm going to be collecting here. Okay. So when you think about these sensors, they all give different values, right? The light sensor, for example, gives me a nice integer, gives me an integer value, a whole number that I can use to store in the database. The temperature sensor gives me a float value. It gives me a decimal. So I have, for example, 26.6 degrees. The moisture sensor gives me another integer, gives me a percentage. So all these values that I'm collecting from these various sensors, the outlet state is a Boolean. It's on or off. It's true or false, essentially. So all these different values, I've got all these different values that I need to track, and they're of different type. So it becomes a little challenging when you think about that to store that in a database. Now, I could create different tables for all of these different types of data. I could create a different table for each sensor, but that's not very flexible, right? It's a little time consuming. And what if something changes? What if I decide I want to store the temperature as an integer? Now I've got to change my schema. What if I added a sensor that is saving a different type of value? So you can see the challenge here is that I've got all this various data. It's semi-structured, but it's not completely structured. And I want to maintain that flexibility, but at the same time, I still want the ability to report on that data. I still want the ability to aggregate that data and sum things up and get averages and things like that. So for me, it made sense to store all this data as a JSON object in my database. So every time I took a reading, every interval that I published a reading to that messaging queue, I published it as an actual JSON object. And the really nice thing about the way I chose to store that is that I was able to do that directly in the Oracle Autonomous Database as a JSON object. So if we look at the table that I used to store the readings, you can see that I have 3 columns. I have an ID column, which is just an auto number primary key. I have the reading column, which is a CLOB, character large object, and I have a timestamp for that reading. So I can do things like, aggregate by time and group by time and things like that. So a very simple table, but I also have a constraint on that table. And if we look at the constraints for the table, you can see that the reading column has a ensure JSON constraint that basically ensures that the reading itself is a valid JSON object that's getting persisted to the database. Now, this is important because then I can come back later on and I can query that data as if it were that JSON and do cool things like this. So if we take a look at the table, we'll do a quick select all. And you can see a JSON object for every reading here. So in this case, I have a reading from February of 2021. The outlet was currently off. The air temperature was 69.44 degrees, soil temperature, so on and so forth. This was my reading for that particular time-stamped interval. Now, the really cool thing is that I can go into the table, and I can actually query the values within that JSON object as if they were actual columns in the database. So if I wanted to pull the outlet state out, I can just reference that reading column and then the actual key of that JSON object directly like that. That means that I can pull all those values out of that JSON object and query them and aggregate and do all of that reporting that I needed to do. Now, what happens if I type a column name that doesn't exist? I get a null value. So it basically allows you to be really flexible with the way you persist the data to the schema, and at the same time, keep that ability to do aggregations, to do summaries, to do joins against other tables if I had to, in a really flexible manner. So to me, I think that was one of the cooler parts of this project, to be able to store that JSON in the database and handle it just like it were actually stored in a column. Now let's take a look at the Arduino code. So the Arduino programming language is what is used to program these small microcontrollers. For example, the Node MCU that I used in my case is an Arduino compatible board that has Wi-Fi capabilities. So I use the Arduino programming language to program this. And if you're not familiar with Arduino, it's essentially a very similar language to C++, but it allows you, it is a little different, but it's based on C++. They do have some built-in functions and things like this that are very specific to the Arduino platform. Personally, I'm not a C++ programmer, but I find it rather easy to work with for basic stuff, for reading sensors and flow control, loops, switch statements, things like that. They're not very hard to do. So for a simple program like this, I found it rather easy to work with. Now, essentially an Arduino program at its very minimum has two functions. It has a init method, or actually a setup method that is ran the first time that the board is powered on. So you do things here like configuration, setting up your connection to Wi-Fi, all the things you need to do one time when the board starts. And then there's a loop function, and this loop function is called over and over and over. You can add, of course, other functions as needed, but at the very minimum is a setup function and a loop function. And a loop function just runs consistently over and over until the board is powered off. Now you can put delays in there if you only wanted to run the loop every 60 seconds, every 10 seconds, however often you wanted to run it. You could, of course, sleep the code at the end of that. So essentially, to read sensors, there's a couple built-in functions. There's to read and write to sensors. There are, depending on what type of sensor it is, if it's an analog sensor like the moisture sensor, there's an analog read function. If it's a digital sensor like the light sensor, there's a digital read function. Now, very simple sensors can be read with just those built-in functions. You just read the actual pin that you physically connected that sensor up to on the board, and you get a value back from that pin. So reading the water level, the moisture level, for example, is very easy. Just analog read, and whatever the current reading is set into a variable. Some sensors are a little more complicated, but there are many, many, many libraries out there. For example, this one on line 2 is called DHT, and this is a third-party library that helps you read from the DHT11 temperature and humidity sensor. So there's a lot of people have done a lot of awesome work. There are a huge open source community surrounding the Arduino platform. And one of the other ones that I like to use, that I used quite often, is the Adafruit MQTT library. So if we look here on lines 50 and 51, essentially this is where I set up a connection to that MQTT server that I have running in the cloud. I pass it an instance of a Wi-Fi client, a server, a port, a username, and a password. And then I tell it what actual topic I want to publish to on that MQTT server. So I've established this readings topic, and now the only thing I need to do is actually publish to that topic. Well, in order to do that, if we scroll down here to the loop function, so this is where I get all of my readings, right? So for example, dht.read11, and this is that actual temperature and humidity sensor that I was talking about earlier. So in this case, I read the temperature, and using the API that comes with the library, I can get the temperature and humidity. The temperature, of course, reads in Celsius. So I want it in Fahrenheit. So I have a C2F conversion function that I call to convert it to Fahrenheit. And I build up these strings, and these strings allow me to display the message on that little OLED screen that you see. At the same time, if we come down to the bottom here, I also build out a static JSON document that contains all of those readings. So for example, the outlet state, the air temperature, the soil temperature, so on and so forth. I set those all into that JSON object. I serialize that JSON object. And finally, I publish those up to my readings topic. So at this point, all of my readings are being published up to that cloud. And if I were to do a very simple, actually, let me open up a terminal window here. So if I were to actually subscribe to that topic, and I didn't plan on doing this, but we should be able to do this pretty easily. Actually, let me do this. There we go. So if I subscribe to that topic, you can see these are my readings that are being published every 1 second. That JSON object is being sent up to that MQTT server. So excellent. I have all my messages being published up to that MQTT server, and now they're ready for the Java application to consume them. So let's take a look at that Micronaut application. Let me go into presenter mode here. So the first thing I want to talk about before I get to actually consuming the MQTT topic, I want to talk a little bit about the persistence. And if you're not familiar with Micronaut, hopefully you are. And if you are, I apologize if you already are familiar with this, but I want to talk about Micronaut data. And Micronaut data is a really, really easy way to persist data into a database, right? You set up your configuration, your data source in a YAML file, give it your connect string, your username, your password, and at that point, you're ready to start creating entities. And in this case, I only have one entity. I have a reading entity, and you can see that here represented by this reading class. Now, the reading class has 3 properties: ID, reading, and created on. And the really nice thing about these 3 properties is they map directly to those columns in my table. So I have a table with the column with these 3 columns. The created on column is underscore delimited, but of course, Micronaut is smart enough to convert the camel case to underscore, and all of that's good. So I've annotated this class with @entity. I have a constructor and just basic getters and setters, and that's it. I just have a very simple POJO here that's annotated with entity, and it maps directly to a table in my database. Very simple, not difficult, or anything that you probably haven't seen before if you've worked in Java. The next thing I do is create a reading repository. And this repository extends the pageable repository interface in the Micronaut framework. So I have pageable repository, I extend that, and I pass, the only thing I need to tell it is the actual class, the entity type, and then the type of the ID. And by annotating that with @repository, Micronaut data has enough information at this point by using introspection and the metadata on the entity itself, the annotations, the annotated entity. It knows enough at this point to give me full CRUD operations. So if I were to actually jump over to the controller where I have this injected and just show you really quickly, I have a reading repository, and I have all of these methods available to me at runtime. And I did that just by declaring that interface. At runtime, I have all these methods because Micronaut at compile time does everything that it needs to do to implement these methods at runtime. So I have save, I have count, I have delete all, delete by ID, find all. All of these methods are there for me, so I can do all my basic CRUD operations. Now, I don't know about you, but writing basic CRUD for SQL, updating and inserting and doing all that sort of stuff is kind of boring and boilerplate. So it's kind of nice to have this ability to get all of that stuff out of the box with Micronaut. So basic CRUD, very nice, very helpful. But what about those report queries that I wanted to write? What about those aggregations and things like that? Those are a little more complicated. And thankfully, I have a way to address that by creating an actual abstract repository, an abstract class that also implements the pageable repository. But by declaring it as an abstract class, I can inject an entity manager into this class. I can store that entity manager, and then I can do things like this, create an actual SQL query and use the entity manager to create a native query and execute that native query. So you do get that flexibility and ease of use out of the box with Micronaut data, but you also get the ability to go deeper as deep as you need to and execute native queries, do anything that you need to do to get data in and out of your database. So very nice feature. It is available in JPA. So, think Hibernate, and it handles all of the sessions and all of that awesome stuff behind the scenes. There's also a JDBC variety. If you just want Micronaut to construct actual JDBC queries and issue those directly against the database, for whatever reason, you don't need sessions or dirty checking or any of that stuff. Now you do have to kind of manually manage updates. You have to manually kind of describe how to perform an update query when you do JDBC. But if you want the speed and actual ability to execute native queries directly against the database with JDBC, it is an option for you. So that's essentially Micronaut data. I don't believe I'm missing anything with Micronaut data. Let me take a quick look over here. Yep. Okay. Excellent. So Micronaut data. Oh, the other thing I should mention is the nice thing also here is that I can use a result transformer to actually get a DTO back. So I have specified these DTOs for my query results as a POJO, and by using the result transformer with the native query, I can get actual list of classes back that I can use in my views. Now, speaking of views, I did write this, of course, as a monolithic application. So I didn't run it in microservice, but I actually do have views. Now, a lot of people don't think about views when it comes to Micronaut because it's kind of been sold as this, not sold, but it really does shine in as a microservice type framework, right? Data, ability to create APIs and backends for your front ends, for your single page applications, things like that. But it also does include support for views. So you can use pretty much any view template language that exists in the Java world: Timeleaf, FreeMaker, Mustache, Handlebars, all of those different view type libraries. You can use those with Micronaut. And if you noticed when I had the page controller up, there's actually a model and view type that you can return to your return from your controller. And this just takes an argument of the view. So you have an actual directory within your resources for your views. So the first argument we pass to model and view is the view name. And if we look over here, I have a home.html. So it actually renders that. And if I open that up really quickly, you'll see that I'm using Timeleaf here. So I use the Micronaut Timeleaf feature, and I'm able to create a view that uses Timeleaf and pass it values directly from my controller, which is really nice. So we've got Micronaut data, we have my views. What about consuming that actual MQTT topic and actually persisting those readings that are coming in every second or so? Well, to do that, I use an awesome feature of Micronaut, which is support out of the box for MQTT topics. And for that, I create a class. In this case, I call it a green thumb consumer. I annotated that with MQTT subscriber. And of course, I also show you really quickly here that I also have the actual configuration behind the MQTT connection. So I give it my client, my username, password, URI, so on and so forth. And I come back to my consumer. So I create this class and I inject some various things into the constructor. But down here, we have a receive method. And I've annotated that with the @topic annotation. And I just pass it the name of the topic. So if you remember back to my Arduino code, and when we use the command line to consume that, I had the topic named green thumb /readings. So every time Micronaut receives a message on that topic, it's going to call this method, and I can handle that message. And it's actually awesome enough to actually convert that JSON string based on the actual type that I type the argument received by the receive method. So in this case, I type it as a map with keys of string and values of object. So the first thing I do is I create a new reading entity from that data. I have a constructor that accepts that map and sets all my setters and getters. And then within that, I use my reading repository to save that reading to the database. So my persistence is very simple, one line of code inside that receive method. Every time a message is received on that topic, it's persisted to my database. The next thing I do here is I send a push notification to my mobile device. So if I show you really quickly here on my mobile device, I set up a little threshold. And if my soil moisture was below a threshold, it sends a push notification to my mobile device. Now, the reason I did this, I should have explained this earlier, is I could have certainly automated the watering of my seedlings based on a certain threshold. I didn't feel comfortable doing that because I wasn't really sure just how much I wanted to water the seedlings. Based on my lack of experience, I was afraid of overwatering or underwatering. So I wanted to kind of have manual control over that process so that I didn't get into a situation where I was constantly putting too much water in or not enough water in. So I wanted this year to have manual control over that process. But by getting this push notification, it alerted me at least when it was below a certain level, and then I could manually come and take a look at it and see if I wanted to add more water or not. Now, next year, I'll probably, knowing what I know now, looking at my reports and my data, I'll probably automate it, add maybe a pump system, and actually directly pump water in when it drops below a certain threshold. Should be very simple to do. Just get a very basic pump system and a bucket of water. When the moisture falls below that certain threshold, I just add more till it reaches a level that I want it to be at. And real quickly, I'll show you this because it's another nice feature of Micronaut. The actual client that I use. So Pushover is a third-party service, and it's a mobile app that you install on your mobile device, and you pay one-time $5 fee, and you can use their APIs to send push notifications to your mobile device. So you don't have to actually code the mobile app yourself and push it to your device. You just set it up on your device. You get a user token that you pass to the HTTP request to the client, and it sends the push notification to your device. Now, the reason I want to show you this real quickly here is it's another really nice, convenient feature of Micronaut, in my opinion, and that is what they call declarative HTTP clients. Typically, if you're using HTTP requests and responses from a Java application, you have to kind of get down into the weeds yourself and write your methods to get and process the headers and do all of this stuff. Again, it's some kind of redundant and kind of boilerplate code that you have to write over and over. Well, with Micronaut, if you annotate something with @client, and that is the base URL for the client that you want to create, and then create methods within that interface, just a signature within that interface for each endpoint that you want to expose, and pass it the actual endpoint, say what it produces and what it consumes, and then just create a signature for that specific client method. At compile time, again, Micronaut will create all the plumbing that it needs to generate this post request, and each of your arguments in that method signature are converted to, in this case, form variables that are posted to that endpoint. So really, again, a nice convenient feature within Micronaut to allow you to post and get and put and patch and do all of those different HTTP methods that you have to do. So injecting that into my consumer, my MQTT consumer, allows me to simply call push message and send that HTTP request just by passing some arguments to it. Finally, down here, I have what's called a broadcaster, and this is injected up here on line 36 into my consumer. And what this does is it allows me to use WebSockets to push that data reading directly to my front end. And again, this is another awesome feature within Micronaut that allows you to create a WebSocket server within your application and use that WebSocket server to send and receive messages to a client on the front end just by implementing the class with some basic methods. And we have an on-open method, for example, an on-message method, on-close, and all of these methods will be called when a message is received, when you want to, when a connection is opened, when a connection is closed. And in this case, we just want to broadcast that message so that reading from the consumer, the MQTT consumer, I want to send that directly to the front end. So this allows me, again, to push that data reading to the front end, update those charts in real time, and have that visualization on the front end. And essentially, that's the entire Micronaut application. There's not much to it because Micronaut helps to make these things very easy for us and makes life really simple when it comes to doing things inside of our Java applications.
Sorry for interrupting you. We
Yes.
have about 4 minutes left.
Okay, I just want to show one last slide and then we'll jump to questions. Let me jump ahead. Okay, so the results. So how did I do? Essentially, I want you to see here that I did pretty good with the results. The soil temperature was a little low on average. The humidity was a little low, but otherwise, all of my metrics, all of my values that I wanted to hit were pretty good. And most importantly, the seedlings were very healthy. And finally, the hot sauce was created a few weeks ago and is delicious and very good. So that is essentially it. There are some links here if you want to read more about the entire process. If you want to see any of the code, you can check those out. And if you want to connect with me at all, here are my socials again. And I, again, appreciate very much you all attending and joining me here today. If you have any questions, please let me know. Otherwise, thank you very much for having me. I don't see any questions in the chat. Excellent.
Learn more.
Todd, we have one question in the chat.
Okay, let me check that out. Okay, what do I think about Micronaut versus Quarkus? I don't have a lot of experience with Quarkus. I'm familiar with it, of course. My opinion is they're both really great frameworks in the Java world. And I think what we've seen in the last few years is Java was kind of at this point where other languages like Go and Node.js and Rust and some of these other languages were the performance, the startup performance, the performance for things like serverless and where those cold starts need to be just absolutely fast, resource consumption, things like that. I think we were at a point in the Java world where, you know, they always say RAM is cheap, right? That's the statement that we always hear. Well, RAM is cheap, sure, but some of our Java applications were taking every single bit of RAM and then some. And I think we kind of got to this point where some of these other languages, some of these other technologies were kind of taking some of that market share away from Java. So we got to a point where we needed to stop doing things at runtime, stop doing runtime introspection, stop using reflection. We were just killing our applications with memory consumption and CPU utilization. So the fact that we've kind of gotten to this point where we're doing so much more at compile time, taking that penalty at that time rather than at runtime, I think is a great thing. I think it's opened up the serverless world for Java. I think it's led to being able to develop, obviously both Micronaut and Quarkus have the ability to generate native images from which, you know, powered by GraalVM. So I think, I don't think it's necessarily a competition. Personally, I like Micronaut. I work with Graham Roche and Bert and some of the other awesome speakers that I'm sure you've seen here at JCon. And so I'm a little biased. I've used Grails much before the Micronaut even existed. So I felt comfortable making the transition to Micronaut myself. And I think they're all great technologies. I think competition is obviously good, in my opinion. It pushes each framework to work a little better, work a little harder, and create a little, you know, more of a competitive edge for themselves. But I think there's room. The Java world is huge. I mean, there are tons and tons of Java developers across the world, and that compile time, you know, AOT type compilation has really kind of changed the Java world. And I think we're going to continue to see more of that, more focus on resource utilization, more focus on lowering our, you know, look what GraalVM has done with the JIT, the just-in-time compiler with native image. I think it's amazing. I think you're seeing performance out of Java applications, Java code bases that you've never seen. And I think that's awesome. It gives us the ability to say, hey, you know, Node.js is quick, but yeah, we can be almost as quick, but still have the very enterprise, very reliable results of Java. So I think there's room for both of them. I personally like Micronaut. I think it's a great team. They do great things. The reason I was first attracted to Grails is one of the same reasons I'm attracted to Micronaut. I feel like it was created by people who solved the problems of creating software applications. They've done this before. They know how to make these things easier. They you know, they've been there before, done that before. So to me, I think it's all great. Use Micronaut. It's amazing. Quarkus is bad. No, I kid. Quarkus is great, but obviously I prefer Micronaut, and I find that it's very intuitive. The documentation is amazing. The support in the Gitter channel, for example, is great. Stack Overflow. It's just a great team. It's a great ecosystem. There's great tooling. The team under Graham has done some amazing work on some tooling for VS Code. You should check that out. So there's a great community supporting it. There's great tooling, and it's under active development. I mean, they're constantly adding new features, fixing bugs, totally open to contributions as well. So if you have something that you want to add to it, you're able to do that and submit that and be a part of it. So yeah, great question. I'm not going to say anything bad about Quarkus. You know, it's great for the industry. It's great for all of us as Java developers, for sure. Cool. Yeah, no problem. Appreciate everybody again. Sorry, I'm running out of time. I hope you enjoyed the session. Please reach out if you have any questions. If you want to see the code, I'll be glad to share links or any of that stuff with you. And again, I don't know how to say, auf Wiedersehen. I know that's terrible pronunciation, but goodbye and thank you very much. Dankeschön. My German is terrible. A for effort. Thank you. Take care.